Hello, everyone.
Hello.
So I think everyone has installed OpenFOAM in your system. So otherwise, if you are facing any issue, we have 3 volunteers: Nikhil, Govind Maurya, and Siddesh. You can consult them; they will guide you. So before proceeding further, you should have also this ParaView. Make sure that you have also this ParaView installed externally. So to install the ParaView, you can use the version more than 12, 5.12, 5.30. Any version you can install. And if you are using Windows, then you should have that .msi. Without MSI, it is used. So have you has everyone installed ParaView and OpenFOAM? How many of you are using Linux? It's completely Ubuntu. And how many you are using Windows? Okay, so I think Windows has the everyone correctly installed and OpenFOAM also. So if you have any, then please consult with the. So before proceeding, I think we can start with the Ubuntu. So Ubuntu 18.04, since we are using OpenFOAM 6 version, so this above version of Ubuntu is not compatible with OpenFOAM 6 version. So if you type OS6, so correctly just try to open the Ubuntu and type OS6. So it should create the OpenFOAM 6 environment. As soon as you type OS6, it should create the OpenFOAM 6 environment. And to check that whether you have installed correctly, you can type simple form help. So it should give you the options related to the simple form. And if you are seeing these options, means that OpenFOAM has been correctly installed. Sorry. Okay. So you should type OF6 and then simple form help. So after you should get these options. It means that OpenFOAM 6 is correctly installed. And here you can see the OpenFOAM 6 version is showing on the screen. Externally, you can type ParaView. Okay, so if you are getting this results, then I think you have correctly installed everything. Please raise your hand if you're facing any issue.
वॉलंटियर कितने 3 है क्या उनको बैचेस देने हैं एमबीए
आप नहीं हो गया ना? आप
मैं
नहीं
यही हूँ मैं यही हूँ
installed. So please raise your hand if everything okay in your system. I think we can proceed now. So let's see first installation that I think you have already done, but this should understand first. So to use the OpenFOAM, mostly we require a Linux distribution. Linux means either it is Ubuntu or CentOS. So this kind of distribution is required. So for that purpose, you can use the four method. Either you can use the Linux, that is the most easiest way. So if you are using Linux distribution in your system, then I think you don't face any issue. Otherwise, you are using a Windows, then you can use the WSL. And another option is the virtual machine. So this is the link that I have provided. That is also open source. And from there you can use the virtual machine. And otherwise you can use the Docker. So in Mac systems, generally it is by Docker because of the some compatibility issues. Some of the libraries are not compatible with Mac. So that is why Docker version is better for the Mac type of system. Now, as soon as you want to install the WSL system, so you should first check that whether virtualization is enabled in your system or not. So since you are already using WSL, so I think it is already enabled in the system. And after that, you can use this following steps to install the WSL, and then you can use this last link where from where you can install the OpenFOAM 6. And mainly, majorly I found that most of the people face the reason. This is the most error while you are installing the WSL kind of distribution in your system. So this is generally because this virtualization is not available in your system. So first of all, this is the most of the people face this issue. So if you are facing any kind of issue related to WSL, just try to follow the first step that I gave. So I think since you are here, you have already WSL, Ubuntu, and OpenFOAM. So now we can go to the our first workshop.
प्रेजेंटेशन मोड में कर लेना पीछे दिखता नहीं प्रेजेंटेशन मोड
Okay, okay. So can we start? So myself, let me first introduce about myself. My name is Pratyush and I completed PhD from here. And I started working on OpenFOAM since 2019. And believe me, it was very hard for me because there is no one guy who is correctly working with OpenFOAM. So I struggled a lot. And currently I'm going to, this is because I have one YouTube channel and you can visit this YouTube channel. And my OpenFOAM content is also available on this wiki.net. And if you find, if you want to find CD tutorials related to OpenFOAM, even in So this link you can prefer for any kind of application you want working with. This is an open source link where many people has contributed their tutorials on this link. So this is very good link if you want to learn about OpenFOAM application related to around. Don't be fast. I will explain everything from starting from the command to the running of your tutorial. Don't be hurry. So this link you can refer. I will share with the slides. So don't worry about this. But this is the good link if you want to start with OpenFOAM, starting from the primary tutorials related to OpenFOAM to advanced tutorials you can find on this link. So now before proceeding to the OpenFOAM, we should have some idea of the Linux command. So let me just I think you can start your terminal. You can start terminal and let's just learn about the sum of the command. That is very helpful when you want to use the OpenFOAM efficiently. So these are the limits. I will share you the slides, so don't need to write here. But we can see the practical how is this how this command is going to be useful for you. So first type F6. So basically as soon as we type F6, we generally create the OpenFOAM 6 environment. Okay. So good thing about the terminal like command is that you can open the multiple terminal at a one time. So if you see that here they created OpenFOAM 6 environment and here we does not created OpenFOAM 6 environment. So if I type simple home and help here, so it will recognize that what is the simple home. And if I type here simple home, so it is going to error. Okay, so you can see that going get what is the simple home. But if I type here, it will going to show that what is the simple home. So basically, as soon as you are typing OF6, then you are creating the OpenFOAM 6 environment. Okay. So now this env command. So env command is going to show you the all of the environment variable that is correct that is currently working with the your given terminal. Okay. So for example, if I type in this terminal, that terminal that you are seeing on the screen, if I type here env, so you can see that these are the different environment variable is active currently with this given terminal. Okay. So you can type env and you can see here that different variables is active on the current terminal. Now if you type env here, but where OpenFOAM 6 environment is not created, then you can see you are not going to find any environment variable related to OpenFOAM. So you can see that these are the only variable without OpenFOAM 6 environment. But when we have created OpenFOAM 6 environment, then we have many variables related to OpenFOAM 6. So you can see that foam user libin, WM project directory, foam job directory. So these are the variable environment which is related to the OpenFOAM 6. Okay, so this is not something related to OpenFOAM. This is just a Linux command. So you can use this environment variable to know that different environment variable in the given terminal. Now this is the pipeline. So when sometimes it requires that you need to connect two different terminal command. So for example, this is the env is one command. This grep is another command. So if you want to connect these two commands, env and grep command, like this, you can type here and you can only look for the commands which is related to the OpenFOAM. So let me type here. So you should also work with me, means whatever I am typing, try to type. So this is the ENV, the first command that is click. Then we can use the to connect the command. And second command is the grep command. And we are trying to all the commands related to open form only. So for that purpose, type here form this. And if I type here, you see that all the environment variable from 6 is showing on the screen. So these are the variables that is specific related to open. So I think you have now ENV and what is this pipeline command and what is the grep command. Okay, so while you are going to the solvers, you want to go with the solvers, there is this grep command very important, and maybe we will see tomorrow tutorials. Now there are some other commands that we are look further. CD is command that is to create the directory. Okay. So if you type here list, this means you want to list all the folders present in the current directory. Currently you are in some directory. I will open the terminal, you are in some directory. So you want to list what are the different directory present at the current location, then you can type the ls. So you can see that different directory is here, like CFD tutorials. In your system, there may be some other folder. Okay. So this ls command you can use to list all the directory available at the current directory. Sometimes you want to know that what is the present location. So you can use the pwd command. PWD means present working directory. So if you type here, it will show you the location. So currently you are working in the home and your user home directory you are working here. Okay. Now we have this different folders, that is the CFD OpenFOAM and Tut1 and Tut2 folders. Suppose you want to go to the some OpenFOAM folder. So then you can use the cd command, that is the change directory, and you can type OpenFOAM. So directly which are present in the after listing the using the ls command. And after typing in the cd, you can see that to the OpenFOAM folder. So if you type pwd here, then the location will be your user home and then OpenFOAM folder. So this is the command that is pwd. Okay, and ls command. So ls command is used to list the different directory available to the current folder. Now another important command is the mkdir. That is the creating a new directory, making a new directory. Okay. So let's create one folder in your run folder. So it is always advised to create your own folder, and always whatever you want, either you want to make a solver or you want to create a tutorials, always it is advised in that run folder. Okay. So let us create one folder in your run folder. So please type cd and then type mk make a directory with the name of the run. Okay. So I think in my case this folder is already, I cannot create this directory. But in your case, if you have not any such directory, you can create one folder. Just type mk. Yeah, because already maybe you have already the directories present. Okay, there is no any file. How many of you have created this run folder? So if you want to check whether this directory is already present in your case or not, you can type here cd and form run. So you can see that I have directly landed in my run folder. So you can type cd open. You should have your user name and then there should be run folder. So if you are facing any issue, please raise your hand. There will be volunteers, they will help you out. See, if you are not able to create a run folder using this command, then you can create it manually. So how you can do this manually? So go to the CD OpenFOAM. So OpenFOAM is installed in user home folder, and here you can create one folder with the name of your user. So in my case, user is Pratyush. So I can create Pratyush 6 and run. So you can create using the manually. You can create this folder. Otherwise, this command should work. Okay, if you are facing issue, this means that you have not created the OpenFOAM 6 environment. In that scenario, you can use the open. First, you create the OpenFOAM 6 environment. How many of you created folder? Created? How many of you created? Please raise your hand. Created? So sometimes also we use this echo command. If you want to print something on the terminal screen, then you can use the echo command. Suppose you want to print hello world. So in that scenario, we can use this. Okay, so this echo command you can use to print the something on the screen. Okay, so we have already created the OF6 environment. And some the variables that you have find for the OpenFOAM 6. So sometimes you want to know that what are the different variables. So for example, we have foam SRC variables, foam run variables. So you want to know that what is this foam run. So in that scenario, you can use this echo command. Okay, so you can see that this variable is suggesting that it is a one location, and the location is the your home run folder. Okay. Similarly, we want to know that what is the foam SRC. So this is going to print the location which is given at the foam SRC. So echo is command that is used to print something on the terminal. Okay. So these are the commands which is going to be used while using the OpenFOAM. Here some of the tasks I have given you. So you can try to try to do this task. I will share this slides. This is the some other task, and I have given the solution also. So this is the task that we need to complete, and this is the solution that I have given you. Okay. Why not you just try? It will take hardly 1 or 2 minutes. So these are the same command that is going to be used, and try to complete this task. So just open the terminal and see that what is the project directory, and try to go to your run folder. Then list all the folders and create a one directory which is named as the Linux command. And give the Linux command folder with a text extension. Okay, first open the terminal. Then you can use the PWD. So which is going to suggest you the what is the current working directory. Now you can go to the your run folder. So this is solution you can see. Just follow the command that are given on the screen. So open the terminal, then type pwd, then go to the cd form run. Of course, you need to create the OF6 environment because this form run will only work with the OpenFOAM 6 environment. So we have opened the terminal. Then if I type pwd, it is going to show you the present working directory. And before typing this form run, I need to create the OpenFOAM 6 environment. So now I can go to the my form run. Okay, so currently I'm in my form run. And here I can list using the ls command. I can list all the yes, sure. So I share the PPT in the group. Okay. So after that, we can type this is mkdir and we can create one folder that is the Linux command. So we can type okay. So if you now put this ls command, then you can see that there is now one folder with the name of the Linux command. So now we can go to this folder and I'm typing Control L. So if you want to clear this screen, so you can on your keyboard you can type Control L, so it will clear your screen. Okay. Now we want to create one means .txt file. So we can use the touch command. Okay. So we can use the touch command to create one txt file. Now you can see here that there is one .txt extension file has been created. If you want to open, we can use any type of editor. So maybe you have a notepad editor, or you can use the Genie editor. Okay, so in my case, this Genie is not installed here, so I can use the VI editor. Okay, now I can type anything if I want. Okay, now I have saved this. So this is the complete task that we are given. Okay. So these are the major commands that we are going to use while learning the OpenFOAM. So this cd, pwd, mkdir, ls, and touch command. Okay. So please try to practice as much as you can. And these are the, if you want to learn more about the Linux command, you can go to these references. Okay. Now let's start the OpenFOAM. Can we start OpenFOAM now? Please raise your hand if you are facing any issue. See, if you are using the theme editor, then you might you are facing problem with typing. So better to use the notepad or kind of editor. In case you are not able to open this text file on the screen, you can just use it manually open it.
मेरे ख्याल से बैश आरसी वाला इनको नहीं समझाया क्या एनवायरनमेंट सेट करना क्योंकि जब इन्होंने mkdir कर रहे हैं ना तो वो हो नहीं रहा है
परमिशन मैक में आता है भाई।
वो मंटू है कुछ किन्हीं लोग का शायद
नहीं, वो
WSS में
फिर उनका इंस्टॉलेशन में कुछ इशू होगा, वो इससे कुछ मतलब नहीं।
ठीक
So if you are unable to edit the file from the terminal, you can just go to the folder manually and you can use any type of editor. So here, from here you can open this file and you can type it. Okay. If you are facing problem with the terminal, then you can manually do it. Okay, but effectively, if you want to learn programming, then it is advised to, as much as you can use the terminal, it is more effective. Okay, I think we can start with OpenFOAM. So how many of you are using OpenFOAM for the first time? And how many of you are at the intermediate level? And few faces I can see for the advanced level. They have come for this tutorial. So I think all the kind of people you can see that some of you are the beginner, and some of you are the intermediate, and some of you are the advanced. So I am promising that you are going, you are at whatever level you are here, but you are going to gain something from this today's discussion. Okay. Now, what is the OpenFOAM? So, OpenFOAM is basically used to solve the CFD kind of problem. Currently, you can also use for the some other type of problems like Lagrangian problems or FEM kind of problems. But basically, OpenFOAM is majorly used for the CFD kind of problems. So, what is the CFD? CFD is the numerical approach of solving fluid flow, heat transfer, and associated phenomena like energy transfer and the chemical phenomena. Okay. So in simple, we can say that we solve the partial differential equation. Actually, phone में वो फिर terminal नहीं open हो रहा है, so that's why. So basically, it is tool to solve the partial differential equations, which involves the mass conservation, that is the continuity equations, momentum conservation, and the energy equations. Now there are other tools also to solve the CFD problems, and those are the commercial softwares like ANSYS, but they both have some pros and cons. So like commercial software is the paid license. Okay. So if you want to use ANSYS, in industrial level, it costs around 50 lakh for the 1 year. So if you want to use the ANSYS software, but OpenFOAM is a free software. It is majorly meant for the Windows commercial software, and it is meant for the Linux, which is also a open source operating system. And commercial software is the closed source, it is open source. So why it is important that it is a closed source and it is open source. So for example, if you want to do the major modification in some of your solvers, so in ANSYS it is very hectic task. Okay. For small modification you can do into the ANSYS using the creating some macros. But if you want to do the major changes in their codings, it is a very hectic task. But since OpenFOAM is open source, you can easily download it and you can easily do the modification whatever you want. So that is why OpenFOAM is preferably used in the academics and it is preferably used by the scientists. But it is generally used by the industrial problems where you need to do the post-mortem jobs. And basically this commercial software like ANSYS is known as the colored fluid dynamics. Why it is said that? Because whatever geometry and whatever things, boundary condition you are going to provide to the ANSYS, it is going to give you some color diagram. You don't know what is solving the equations, what is the physics is happening behind the system, but it is going to give you a very good color diagrams. But in OpenFOAM, if you don't know the physics, if you don't know the governing equation, if you don't know the boundary condition, you are not going to get the correct result. So that is why it should be preferred in academics and research in the scientist. Now, it is basically advised that if you want to learn the open CFD software, so you should have some idea about the mathematics, fluid mechanics, and fundamentals of the CFD. Then you should go to the softwares. Okay. So I think most of the people here from the mechanical backgrounds and aerospace backgrounds, so I think these concepts are somewhat clear in your mind. So that is why we are organize this OpenFOAM workshops so that we can have some basic idea about the CFD softwares. Now let's what is the OpenFOAM? Means OpenFOAM majorly used for to solve the field operation and manipulations. Okay, so if you see the governing equations, so this governing equations has the fields like this velocity is also one kind of fields, temperatures. So the operations and manipulation related to this whole field is happening in the OpenFOAM. Okay, which involves the fields, meshes, discretization schemes, interpolation schemes, equation of states, display particle system. So this all involves related to the OpenFOAM. Okay, so don't worry about if you are not having idea and don't make this kind of faces. Once you learn the software, you will learn about these things. So basically, this yes, which is the pioneer of this OpenFOAM software. So in his simple language, OpenFOAM is excellent piece of the C++ and software engineering. Okay, so apart from the CFD, even if you have some partial differential equation, if you want to do some C++ coding, I think you can use OpenFOAM environment. Okay, so if you have to any kind of C++ coding you want to do, you can basically use OpenFOAM environment. That is why it's better to say that it is not a CFD software. It is an excellent piece of the C++ software. Now let's see the OpenFOAM structure. Okay, now we are going to understand the OpenFOAM folder. Okay, then we will go to the tutorial case. So again, parallelly, you can also open the terminal with me. So if you open the terminal, we are going to understand the folder structure of the OpenFOAM. So first we need to create the OS6 environment. Okay. So now if we see, if you go to the this folder, that is the working project directory. Okay. So we are into the OpenFOAM 6 folder. Okay. So if you list here, you can see here there are different folders in this project. This all make bin folder, etc folder, SRC folder, tutorials folders, application folder, doc folder, platform, test and document. Okay. So everyone is able to see these folders, all make bin, etc, SRC tutorials, application, doc. Okay. So if you remember while you are installing your OpenFOAM, everyone has used this command, all make and minus J and 4. I think everyone has used while installing the OpenFOAM. So basically you are running this folder, this compilation folder. You are trying to compile this all wmake command to compile the OpenFOAM. Okay. So whatever the installation instruction is given here, that is present in this all make. This is kind of a text file where all the installation instruction is given. That is why as soon as you run this command, OpenFOAM is going to be installed. Okay. Now these other things, other folders. So for example, after all make, this application folder is important for you. So if you type applications, so there you are going to see the solvers, tests, and utilities. Okay. So the solver contains all the governing equation that you want to solve. So there are different problems as the different solvers that is given here. Okay. So basically, like if you see how OpenFOAM works, suppose you want to edit an image. You have image, you want to edit that image. That image is a kind of a test case. That image that you want to edit and you want to make a image good photo. That image is kind of a test case. And that application that you are using, that is kind of a solver here. Okay. So without using the solver, you cannot do the process to the given image. Okay. So this solver is kind of the application that you want to use. Okay. So these are the different solvers for the different physics. There is a different solvers. For incompressible kind of problems, you have a number of solvers. Compressible kind of problems, you have a number of solvers. Combustion problems have a number of solvers. Okay. So basically, based on the problem definition, you are going to use a given solver. So this is just an app, but without given an image or without a given text case, you cannot solve your problem. And where this test case is given, so in the tutorial case, if you go, so here you can see that whatever solver is given here, so these are the DNS solvers or different solver is given here. Similarly, here you can see that there are different tutorial cases are given here. Okay, got it? So for example, you want to you have some image, you want to make some process to that image, you want to enhance the image quality. So then you are going to use one application. Similarly, this solver is kind of applications where some different governing equations, different physics is given here, read here. And these are the test cases. That is like image. So this case you can use for your problem. Okay, got it? So these two folders is very important for you. This solver folders, this tutorial folders. Okay. So you want to again, so here, I think you are here. Now you can go to the tutorials. So these are the different tutorials. So tutorial is like an image. Okay, suppose you have image, you want to enhance the quality of that image. So in that scenario, you are going to use some app like Adobe, GIMP ho gaya, Inkscape ho gaya. So these are the applications. So similarly, here these solvers are like applications. These solvers, these are the like the applications, like SimpleFOAM, IITFOAM, okay, ParaView. These are kind of applications. But test case means you have a like image test case that you are going to use the solver for the given test case. Okay. For example, if you have an application, you can use that application for multiple images. Okay, if you have a GIMP, you can use for the multiple images for the same using the same application. Similarly, same solver can be used for the multiple test cases. Okay. So I think this folders is clear to you. What is the solvers and what is the tutorials? Okay. You can directly go to these folders using the foam command. Foam tutorial commands. You can directly go to these folders. CD foam tutorials. You can directly go to that given folders. And foam app commands. You can directly go to the application folder. Okay. So I think what is the solver and what is the tutorials, that is clear to you. Okay. Now there are some other folders. So in application, apart from the solvers, there are some test cases. So generally, if you want to do the coding kind of problems, okay, if you want to understand the coding of the OpenFOAM, in that scenario, you should go to this test folder and you can see the different objects that is created in OpenFOAM. So basically, it is not, I will not advise currently you should go to the learn these folders, but when you want to understand the solvers, when you want to understand the advanced C++ coding inside the OpenFOAM, then you should go to these folders and copy these folders from this test to your run folder and try to see the different C++ snippet given in this test folder. Okay. Generally, people don't follow this test folder, but I have learned programming using this test folder only. Okay. So basically, from small level coding to the advanced level coding is given in test folder. So once you want to understand the programming, then you should follow this test folder. Okay. And these are the some utilities. So after, if you want to do the post processing and pre-processing, then utilities is important for you. Like if you want to do the meshing, then block mesh is one utility. If you want to do the some post processing, like if you want to do the plotting of the given field, in that scenario, this utilities is important. Okay, when it will be required, we will learn this. Okay. So I think this importance is clear to you. Solver is for the given application. That is the ICO simple form, interform kind of the things are given here. Test means if you want to learn the C++ coding, then you can follow this test folder. And this utility is generally for the pre-processing and the post-processing. Okay, understood? Anything you want to ask till now? We have learned about the solvers, test tutorials, and this application folder. Okay, maybe we can see folders also. Let me open. So this is OpenFOAM where OpenFOAM is installed. And in application folder, if you go, you can see that there are three folders is present. That is a solver, test, and utilities. In solver, you can see that different models of the physics is given here, like incompressible heat transfer. And even if you go inside the incompressible, you can see the different solvers name. ICOFOAM, PickleFOAM, SimpleFOAM, SimpleFOAM, Newtonian foam, okay, boundary foam. Okay. Now, application, this is that what I am saying that if you go to, and if you want to understand the programming of OpenFOAM, so like how the object of this, means any kind of the object is created in OpenFOAM, that you can directly open here, any test case, and you can just see the different functionality here. Okay. So basically, if you want to learn the OpenFOAM, different object, how it has been created. So like if this is one of the important things that has to be used in solvers, that you can see, just open the .c folder and you can see that how the code has been given. Okay, so it is something related to the programming. But I think if you want to understand the advanced OpenFOAM, then you should go through this test folder. And this is the utilities, some of the post-processing or pre-processing utilities. So here you can see that the pre-processing utilities, post-processing utilities. That is something related to the parallel processing, and this is something related to mesh. Like you can see that your different how you can create the mesh with OpenFOAM, that is given here. Okay. So these are some tools if you want to create mesh in OpenFOAM. Okay, like if suppose you have taken this from the fluid and you want to convert it into OpenFOAM, these things are given here, and we will learn these things. So just I'm explaining the different folder here. So we are not going into the details here. Okay, and this folder is very understand. This folder is something related to the tutorials. So different solvers and different tutorials is given here. So you can just copy these tutorials from this folder to the your run folder. So it is always remember that don't change the default setup of the OpenFOAM. If you want to do anything, just copy the folder from here to your run folder. And if you want to run or if you want to do the modification, you should do there. Otherwise, in future it is going to show you error. If you do any modification here, it is going to show you because every folder is dependent on everything. So if you do something modification here, it will going to show you error in the some another folder. So it is always advised to copy folder from here to the run folder. That is why I have advised to create the run folder. And then you can do anything there you want. You just run your test case and just delete it, then again copy here and then delete it. So if you open the simple, then you can see other different cases is given here. Okay, like 5 cyclic, some other cases in this session. So this is basically about the application tutorial cases. Now let's see some other folders. So this is bin folder. So So whatever the solvers or whatever the utility that you want to create, okay, generally you compile that solver, and after the compilation, it develop a one application, and the application is stored in the bin folder. Okay, so you can see that these are the application. These folders you cannot open from using some editor. This is kind of one application has been created. You got my point? So suppose you do generally you do the coding. So in programming, it develops a one application that is just read by the computer. You cannot. It is not human readable. So this is kind of the application has been created and it is stored into the bin folder. Okay, so you don't need to worry about this bin folder. You don't need to read here. Okay, this is documentation of this OpenFOAM 6. Okay, either you can install this doxygen, otherwise you can open from the uh, terminal. So you can type the OpenFOAM 6 doxygen. So documentation of OpenFOAM 6 you can find here from the internet. Okay, so you can directly go to the document. You can see the header files here, .c here. How coding practice you do, you want to do coding practice. So these things you can read here. Okay. Otherwise, you can just follow these instructions. Some of the PDF files are also given here that you can use as a user guide. So this doc file is related to the documentation of OpenFOAM. Okay. ADC is something related to the background. Like if you have created the OpenFOAM 6 background, so everything is related to the OpenFOAM 6 background is given in this ADC folder. Okay. For example, while you are installing, when you type this OF6, so this OF6 is creating the OpenFOAM 6 background. Generally, it is going to best etc folder. Okay, and from this best it is creating the OpenFOAM 6 background. So everything related to OpenFOAM 6 background is given in this etc folder. Okay, so that is also you don't need to worry about. This SRC folder is very important when you want to create the libraries. Okay, so there in programming there are three things that you are going to do. First, you are going to do programming related to the solver. Then you are going to programming related to the utilities, and then you are going to do programming related to the SRC, that is the library. Okay, so this is something. What about the different models that you are using? So like if you are using the different non-Newtonian models, different MP skips, different NP solutions. So everything that is, you can say that this SRC folder is the heart of the open. So everything, every different library is given in this SRC folder. Okay. So you can change everything. You can do the modification to the solver. You can do the modification to the library, but don't try to modify this SRC until and unless you are very confident about it. Okay. You can copy this from here to the program folder and you can do the modification, but don't try to change this SRC folder. This is hot or open form. Okay. And this again test. Some of the test cases are given here. Something related to multi-phase and other things. Okay, but for now, only two things is important for you. One is the solvers and one is the tutorial. Okay. Once tomorrow we have some session on the programming, then we will learn about this WMAC and maybe some related to the programming. Okay. I think everything means at least about the solver and test case, everything is clear to you. Now we can do some. We can take some test cases and we can do some. We can run some simulation. Okay. Here. So just open the. Let's copy some test cases. First create OpenFOAM 6 environment. After opening the terminal, create the OpenFOAM 6 environment. Then now go to your run folder. Go to the run folder. Currently, you may have not any. In my case, there are number of folders, but in your case, there should be not any folder. Okay. Let's create one folder with the let's create one folder that is the day one session one, and let's go to the this folder. Okay. Now we want to copy some tutorials from the simple form, and we are going to copy that tutorial into this folder, and then we are going to run this folder. Okay. So before going to copy, let's see that what are the different tutorials is available here. Home tutorials. I want LS means I want to list. Then after home tutorials, I can go to the incompressible and I can go to the simple form. Okay, so I want to list what are the different tutorials is available into the simple form solver. Okay, so you can see that there is a this number of tutorial cases available here. Okay, got it. Now I want to copy this fits jelly case. So let's start with the first case. So for the copying, I can use the cp minus r. Cp means I want to copy, r means I want to copy the directory. And after the simple form, I can take the this. So everyone please also do with me. Fits daily. So this just I want to list what are the different cases is available in the simple form. See, this is the LS means listing. This is the location where I want to list. Huh? See, first I type LS, then I type home tutorials. Okay. Then I press this. And if you type tab, it is going to suggest tab button. If you type in the terminal, it is going to suggest you the options. Okay. After tutorials, if you type incomprehensible, just type INC and type the tab. It is going to give you suggestion. So for example, if I want to do this SIM, then if I type tab, it is going to suggest me the simple form. Tab keyboard button, you can type, it is going to give suggestion. Okay. And if I press enter, then it is going to show you the different. So this button, then arrow button you can use. If you want to know what are the different commands you type, then you can use the arrow button. Then from here I can type cp minus r. Cp means I want to copy, r means I want to copy the directory. Okay. And you can, since you want to copy this folder into the current folders, you can type this dot product. Dot means you want to copy into the present working directory. Now you can visualize here, and you can see here that now we are in the Fits Daily folder. So this CP minus R, and this is the location of the folder, and this is the dot button. Alternatively, you can directly copy from here by manually, and you can paste here. So you can copy from here, just copy button, and you can go to the OpenFOAM 6 and the 6 run folder, and you can manually copy paste here. That you can also do. Okay, so if you see this folder, so this is a problem. You can also copy the manually also. Here, this is the command. That dot button you need to put if you want to copy at the current working directory. CP is used for the copy, and R is for the directory if you want to copy the directory. CP minus R. And then the location from where you want to copy. See, this is the syntax. CP minus R, location from where you want to copy, and location where to copy. Okay. So this is the location from where I want to copy. It is dot because I want to copy into the present working directory. Otherwise, you can manually copy it. Have you copied? So once you copied, you can go to this folder, that is the Fits Daily. So you can see there are three folders, that is a zero, constant, and system folder. Okay, so Whenever you are going to work, these three folders is very important for you. Otherwise, it is going to show you error. Okay. Zero folder, constant folder, and system folder. These are the basic requirements for the test case into the OpenFOAM. Now let's understand what are these three folders. The zero folder is basically the boundary conditions. Initial condition and boundary condition. Everything is given in the zero folder. Okay. And this constant folder, something related to the physical properties and to the mesh. So these are the some physical properties related to the turbulence, what kind of turbulence pattern you are going to use, what is the viscosity that is you are going to use. That is given into the constant folder, and also the meshing is going to be stored into the constant folder. Okay. Now, what are the different time steps that you are going to take, and what are the different discretization schemes that you are going to use, and what are the different FB solutions means tolerance that you are going to use. Everything is given to the system folder. Okay. So you can say that constant folder is basically related to the meshing and physical properties. Zero folder is related to the initial and boundary condition, and system folder is related to the discretization and to the tolerance and to the time scheme. What are the different time steps that you are want to take? That is something related to the system. So that is why this three folder is very important. This three folder is there. Maybe you can find a number of folders, but this three folder is very requirements. Now here you can see that there is a blockness folder, and currently if you open the constant folder, you did not find any information related to the meshing. So for that purpose, you have to run the blockness. Blockness is the, you can say, the meshing utilities. So remember that in application folder there are three different varieties solver. There is title utilities. So blockness is one of the utilities that you are going to use to create the meshing. So if you type blockness and enter, so you can see that has created the mesh. Now, if you again refresh the constant folder, here you can see that you have now one polymesh folder. Earlier there was no any polymesh. As soon as you type the blockness, there is going to find, you are going to find one polymesh folder. Whatever the missing information is there, is created to a directory that is named as the polymesh. And if you want to check the mesh, what is the quality of mesh and what is the size of mesh, you can use the mesh command, and you can see that there are 12,000 number of cells has been created. Okay, and all the cells are having the hexadecimal mesh. So first I type block mesh, then I type mesh. Everyone has discussed correctly. File is checked as a promise. Now let's check. So after that, type touch and this command. It is daily.com. So it is going to create one file like this. Now open the ParaView, and we can import this into this. Okay. So type this daily.com. This is going to create one file with an extension of the .foam, and that you can import into this ParaView. How many of you have created the mess? Huh? Block mess. Oh. So go to the fix inside the folder. Here you can see the zero, constant and system folder. There you need to type the block list. Everyone installed, everyone done this block mess. So you can type this block and then again you can press the tab command. It is going to suggest you the options. So if you type check, so it will suggest information related to this. So you can see here that the cells that we are working 12,000 and the bonding box, see the bonding box, this is the minimum location and this is the maximum location. So the box that we are created as the minimum location is this one and location is this one. Okay, there are boundary patches that you can see, that is the inlet, outlet, upper wall and lower wall. Okay. So I think everyone has done the message. Now open the. So I think I have also created this .foam extension file. Now open the ParaView. Open ParaView. And you can import that .foam folder into the ParaView. Go to the folder. And export this to the folder. Okay. And this you should have click this. Everyone okay? This folder. So what I have done, just type this touch command and You can put any name like it's get.foam. So it is going to create one file with the name of the .foam extension, and that you can export here into the ParaView. Okay. So you can see if you want to see the messages, you can see this is the message that we created. These are the number of cells, and if you want to see the boundary conditions, you can turn on from here. Okay. Now you can see that this is the problem because in the data connection we have only one cell. So everyone can see anything in their ParaView. So if you want to see the boundary condition for the U, you can from here you can see U. So you can see that at the inlet we have applied some boundary condition around 10 meter per second. Other location we have the zero value. Okay. At other location you can say that value is equal to 0, but at the inlet location we have a 10 meter per second. Similarly you can see for the pressure. Pressure we have the 3 value, and these are some values related to the left model. Okay. So only U and T is important for as for now. So everyone can see meshing in ParaView. I think everyone now able to see meshing. Okay. So now we can run the software. Okay. So control here, and then here we can run the solvers. Okay. So remember that we copied the distance from the simple form. So solver that we need to run is the simple form. So type simple form. Okay. And then enter the solver. Just type simple and use the tab command. It will automatically fill the circle. Okay, now enter the. So see that the solver is running. So simple is a steady state solver. So it will try to converge the different field variable given in the folder. And you can see that at the last it is written that simple solution is converged in 288 iteration. Okay. So to get the converged solution, it has run around time equal to the 288. Okay. And if you see how the folder fits any folder, you can see that the number of folders is created. That is the 100, 200, 288. Okay. Okay. Three more folder sizes have been created. That is given. Now we can replace the time here. Yeah. So as soon as you refresh the time, you can see that number of times step into this box. So from 0, 32, 64, 86, 128, 256 and 288. Okay. So for the different iteration, you can get the solution. But since the project solver is the estimate, so there is no requirement for the different iteration. You need to only get the final solution. So that is for the 288. Okay. So this is the final solution. And if you want to do good post processing, you can find the color texture here. So you can change the color from here, whatever specific color you want, just go here. This is U field. Similarly, you can get for the P. This is the pressure field. Okay, so you can see that flow is starting from here, but that is the inlet field. So this is the inlet, and this is the outlet. And that is why you can see that there is higher velocity at the inlet. Okay, so you can see that around 10 meter per second. That is at the inlet velocity. Now, here the velocity is vary means between the 0 and 2 meter per second at the inlet 2. This is the inlet 2. And at outlet, you are getting kind of a parabolic kind of a shape you are getting at the outlet, where the velocities lies between the 10 meter per second to the around 4.5 meter per second. And near the wall, you can see that the velocity is nearly approximately equal to the 0. So near the wall, you can see that kind of no slip kind of boundary condition that you are going to observe. And even if you want to do the plot the velocity field, you can go to the different option like plot over line. So go to the filter, sorry, go to the filter. There is alphabetical filter. You can go and plot the plot over line. Okay. So you enter that. Here you can plot the U 7. So that is velocity plot along the H line. That is along the y-axis. Okay. And Z, since we are only doing the 2D flow, that is why you can plot the velocity plot along the x and y z. So currently, the physics is not important. You should learn how you are using the tool. Maybe we can go in the depth tomorrow's session. Then we will know that what different fields you are solving, what are the different schemes you are using. That we are going to see in the tomorrow's session. But for now, you should means compatible with the tool. That what are the different things you are doing. First, we are copying the test case from the tutorial section. Then we are creating the test. For that purpose, we use the block mesh. Then we run the solver. That is the 3 steps that we are going to follow. Yeah, you are getting this result. So let's I am giving you one exercise. Go to the tutorial section, and from tutorial section go to the incompressible and take one case from the iPhone. That is the cavity. And copy this folder into the run folder and try to do the block mesh. Then see the message and then run the IIT solver. Go to the IIT folder. Just use the terminal command. Don't copy the manual. Just use the terminal command and go to the run folder. From incompressible IIT, there is a cavity. Then inside the cavity there is a cavity. Copy the cavity folder into the run folder. Try to run blockness. Try to run the solver, that is IIT. So go to the incompressible IIT cavity and cavity. Then copy to your run folder. Run the blockness. Run IIT. Get the result. लिखा है ना? Just do the steps से लिखा हूँ. Go to the incompressible IIT cavity. Then copy to your run folder. Then run the blockness. Then run the IIT. And then get the result. Get the result means open into the ParaView and plot the result. Attendance mark करके जाओ. Mark. Give one page and write name of the. Huh? Yeah, 0 constant and 3 files is required. So these 3 files, these are the testers. This will be presented here. So what we need to follow? When I say that go to this folder and copy to the event folder, it means that first you should go to your run folder. Okay. So this is the first step. Then you should first go to the run folder. Okay. Now you can go to the where we are working together. So today's session we are taking to the day 1 session. Okay. Now I can copy this cavity. Now I can copy this folder into this folder. Present working directory. जहाँ पे मैं काम करने वाले हैं लोग, we can copy that folder into that folder. Okay. So for that purpose, I use the cp command. Okay. Minus r, I want to copy the directory. Then I will go to the home tutorial. So just typing the home and you press the tab button. Okay. Then you go to the compressible. So just after typing the I and C, press the tab button. It will automatically write the compressible. Then go to the IIT Bombay. After IIT, go to the cavity. Then again go to the cavity. So this folder I want to copy. So cp is the command. Yes, I want to copy the directory. So I put -R. And this folder I want to copy. Huh? No, just you put, so just put the ICO and then press the tab, then cavity, then press the tab. So yeah. So this folder inside the ICO form there is the cavity test case that I want to copy. See, if you are facing an issue, you can directly copy from here. You can test there manually. Right? CP -R home you can type through then press the tab. Okay. Then type this command, then type INC, then press the tab. Okay. Done. With everyone on the same page. Then I type ICO, then press the tab. See this. Okay. Then type cavity, then press the tab. Done. Then again type. Then since you want to copy into the present directory, that is why you have to add this dot button. Dot. Dot means present working directory. Okay. Now press the enter. So if you now type ls, you will see that there is one cavity folder. Now everyone has done copy. If you are not able to copy, you can manually copy from here and paste in the your run folder. So you can copy from here, go to the run folder, you can paste here. So you can directly go to this OpenFOAM user folder, then run folder, and you can directly paste here. Okay. Now go to the cavity folder, CD cavity, CD means shape directory. Go to the CD cavity. Now you can run the blockmesh. Just type blockmesh. Then open the mesh into the ParaView. If you run blockmesh, then So if you type block mesh, you can see that it is creating the mesh, and you can check the mesh with the check mesh command. So you can see that it has around 400 cells. Earlier there was 12,000 cells. Now it has only 400 cells. And the bonding box is also smaller, 0.0, 0.1, 0.1, and 0.01. So this is the complete box geometry. And if you want to see the mesh, you can type the touch command. And after the touch, you can use the cavity dot form. Okay. You can use the touch command, and then after that, cavity dot form. Dot form is the extension of the file. So after that, we have one file with the name of the cavity dot form. That you can open into the ParaView. So this is the test for the cavity problem. Okay, so you can see that there is very less number of the cells. I think 20, that is 400 number of cells in the x direction, so 20 cells in the x direction, and 20 cells in the y direction. And in Z, you have only one cells, so that is also a 2D problem. Done. Now you can run the IIT. This we copied this test case from the IIT test case. So that is why you have to use the solver that is the IIT. So you can type IIT, and then you can use the enter. Press enter. So it has taken only 0.5. Okay. Since you are creating the current number, so it is a this is not a steady state problem. It is a unsteady problem. I give you know the difference between the steady and unsteady solution. So here you can see this is the coherent number. So this is the unsteady state solution. Now you can refresh here. Just press the refresh. So this is our time step equal to 0.05. This is velocity period at 2.1. This is velocity period at 0.16. This is for 0.33. This is for 0. Okay. Now if you want to see the structure at the mid plane, then you can take the size. So if you want, suppose you want to just take a one plane. So for that, what you can here you can see the different options at the top in the left side. Here you can see the different options, that is compute, isosurface, flip, and slice. So you can press on the slice. That is the fourth option. This option. Okay. Now here you can take that which plane you want to take. Either it is x normal, y normal, or z normal. So this is the z normal. This is the x normal. This is z normal. You can see that this is the mid plane at the z normal. So this one is the perpendicular XY plane. This is the mid-plane velocity profile. Okay. Everyone got this kind of the profile. Go to the size where the fourth option. Then after size, you have option which normal you want to take. So since you want to take XY plane, that is why you have to place here Z normal. Then place the line. So this kind of the profile you want to take. If you want to change the color, you can go to this different color box. Similarly, so everyone is able to get this contour. This is called time step equal to 0. This is the 0.1. This is 0.2, 0.3, 0.4, 0.5. So I think everyone now copy test case from the tutorial folder and you can run by yourself. Huh? So let's take one example from the multi-phase problem. These are the simple case. We are not going to understand the interface, how interface works. We are going to just a copy test case from the interface and we are going to run the solver. Okay. We are not going to understand the interface because it is a multi-physics problem. Okay. Can you copy by yourself? You can take one test case from intercom. Just copy here. Just run the solution and plot in the form. ParaView. So there are three number of solvers. So from here we are going to take one case from the from multiphase. So go to the tutorial case. Then inside tutorial, go to the multiphase. Okay. We have a number of test case. After that, we are going to take case from the intercom. Okay. From intercom, we have a laminar problem. So we can take any case from here. So let's take this dam break problem. You can copy from here either manually or you can use the terminal command. So let's for this let's copy manually. So I copied it from here. ओके, कॉपी हो गया क्या? सब कोई कॉपी कर लिया क्या? So I think everyone has copied this second folder. Great. Everyone has copied inside their run folder. So let's copy manually from here and let's go to the my user folder. Okay. So this time I am copying using manually. You can either use the terminal command or you can also copy manually. Here I copied. Okay. So that the thing that I want to explain here that you should always know that which solver you want to use. Okay. So since I am copying from the multi-phase problem and since the last folder I am copying from the interform, the solver that I am going to use is the interform. So if you see here that this is the physics that is governing. So like this is combustion problem, it is a compressible problem, DNS kind of problem, heat transfer problem, incompressible problem. And we have taken our case from the multi-phase problem. Okay, so once I open here, these are the solvers name. Okay, so as soon as you the last name you are seeing the foam, FOAM. So it means that that is the solver name. Okay, so here you can see that there are a number of solvers name are given here. So this is the cavity form. So whenever you copy any test case from this folder, you are going to use the solver is equal to the cavity form. If you are copying any test case from here, you are going to use the compressible interform solver. And this is the compressible multi-phase interform. This is the drift flux interform. Since we copied our case from the interform solver, so that is why the solver that we are going to use is the interform. Okay. Got it? This solver you are going to use. Still, if you are confused, then there is another solution. If you open the tutorial case, so suppose so if you open the tutorial case, there is one text file that you can get. So this text file you can open with any, like I can open in the notepad. So here is given that what are the different applications that you need to run. So if you had to run the blockness, then after that you have to run the set fields, and then you have to run the application. And if you open the control dict here, so if you want to know the solver name, you can open the control dict folder, and here you can get the solver name. So here you can see that the application name is interform. So this is the solver now that we need to use. So in repeat tutorials, there would be control dict files inside the system folder. And in that control dict, you can get the name of the application or the name of the solver. Okay. So if you are confused that which solvers you need to use, just open the control dict file and the first line is given the application name, that is the name of the solver. Okay. So let's run this problem. CD, if I press 2 times dot, it means that you want to go one folder back. Now I can do that back. Okay. So this three folders is important: zero, constant, and system folder. Okay. Now I can run the block mesh. Okay. I can run the block mesh. After that, touch for the getting the mesh. Yes. And after that, Okay, so this is the mess. Okay, so this is the mess. In here label size you can put 64 bit. If you are getting the difference, if you are getting the error, then you can put the 64 bit. So everyone has done this block mess. Everyone has completed this block mess. So now you need to run the not the solver. So that is why this all run is given. So to understand that what are the different commands you need to use, you should always see this all run folder. Okay. So if you open the all run, here you can see that after blockers there is a set fleet also. There is also set fields. So if I if I plot this alpha water, you can see that everyone is the value 0. This alpha water everywhere is the value 0. This is alpha water. Here you see this different variable is given. This is alpha water. Okay. So now you can see that everywhere the value is 0. Okay. So let's run this set field graph. Set fields command. Okay. So where I get this idea that I need to run the set fields. So for that first you need to open the all run. And in all run you can see that after block mess there is set fields. Then after that there is a solver. That is enter command. So if you open the all run, you have some basic idea that what are the different commands that you need to run. So already in every folders you are going to get this already folder. Okay, so that is order. Okay, so if I run this set fields, and now if I finish this, ParaView is not showing the updated version of this alpha water. Actually, ParaView is not updating this value. That is alpha water. We want to show that value also. Yeah, now you can see. So earlier you can see that everywhere the value was 0. Now you can see that this is the value equal to the 1. Okay. So this is kind of a problem that there is one dam is created. This is like a dam, and this is the water that is going to splash the dam. This is the dam that you can see here. And this how the physics is going to work. So that is why it is known as the multi-phase problem. So other environment there is a water equal to the 0, and only this section has the water. Okay. So as soon as it is going to hit this dam that you can see in the small zone, and how this is going to work, that you can see using the interform solver. So now we are going to run the interform. You got what you are going to solve here? Okay, so what we can do, So let's just follow few things. Just go to the system folder and open using the notepad or any editor, any different editor. Here you can type ASCII. So earlier the file you are creating, which is kind of binary file, that you want to change as a ASCII file. Okay. Just we don't go into the details for now. Have you done it? Now open the terminal. Okay. Go to the 0 folder. Open the terminal. Go to the CD0 folder. Okay. Everyone done? Now type CMV. You want to move this alpha.water.org. Okay. So there is one alpha.water.org in case of your problem. Okay. When you are typing ls, there you have one alpha.water, and then you have a alpha.water.org. Right? So type mv alpha.water.org. Okay. And means you want to move this content, whatever the given in that content, to the different folder. That is the alpha.water. So this you type move alpha.water.org, then alpha.water. So it means that whatever the content is given in this folder, you want to copy into this folder. That is alpha.water. Okay, update enter go. Done. Everyone else done. Now type this set field command. Now type this set field command. Okay. Now create .foam folder and then upload into the ParaView. Now create this top search. Then create maybe what any that name you can give anyone. Then break any okay. IIT anything you can give. But that extension is important. That form extension is important. Done? What? Oh, sorry. Anyway, it is not going to work if you create in 0 folder. Okay. So now you can open into the. Now you are getting. So if you are facing any issue, just put it here 64-bit. So you plot a alpha, so you get something like this. Everyone is getting. I will type technique. You are getting like this. So that this is kind of multi-phase problem. Multi-phase means you have two different phases. So this different zone is like air, and this is water. So when it is going to hit this dam, that is you are trying to mimic like a dam. Then you are going to see that how physics is going to work. Yeah. So that you are going to solve the interform. How can I done? So if you done now, you can run the solver. So the solver name is interform. Okay. You run the solver. Now you can access here. So you can see that how this beautifully is executed. Okay. So earlier, so at the time step equal to 0, the water is like a tank here, stored here. But as soon as this tank is broken, you can say that how it is going, and it's going to hit the dam. So you should see animation like this. So this is a kind of multi-phase problem. This is one simple problem. Let me show the problem where on which I am working on. So I am working on a. This is I am using the same kind of multi-phase problem. I am working. I have done some modification into the solver. So this is a kind of latent frost droplet. Have you heard about the latent frost? Have you seen that when someone is cooking on a what we say plate, so water seems that levitating over the surface. Have you seen this phenomenon? जहाँ पे चाट पे बनता है, वहाँ पे ऐसा seems like the water is levitating over the surface. So that kind of phenomenon is known as the latent frost phenomenon. So I am trying to study that phenomena using the OpenFOAM. So So my different time step control, I restore the control plots. So you can see that how droplet is going at the bottom. This is the for the different type step. So you can see that how this water is not touching the surface. Okay. So this red zone is the means droplet, and the other zone is the air. So this is how you can means work with the interform kind of problems. And today you have only learn about how to run the test case. You can take different cases from the tutorials. You try to run by yourself. And if you have anything, then you should just share me the screenshot in the group. I will help you out. Tomorrow we are going to learn about the programming. Okay. So we will do some basic programming. Then we will learn the CFD simple code solver. Okay. अरे वो स्किप जीरो जो है ना दो सेकंड उसको अनक्लिक करो अप्लाई करो अल्फा डॉट वाटर नहीं अल्फा डॉट आ गया ना नहीं इंटरफॉर्म आप सिम solver name देखना है ना you go to the system folder then is a control dict in that folder you can see the solver name so try to take different cases from the tutorial folder and try to run by yourself any questions anyone all run में नहीं all run में application लिखा है so that is why actually you can see that interface is not captured accurately. So in that scenario, you have to increase the mesh size. Actually, it's just a test case diya na, that when you go to the research problem or academic problem, then you have to play with the mesh size. Okay, anyone, any questions? Slides को सबको मिल गया. Maybe I will put some one or two exercise that you can practice by yourself. Okay. Or tomorrow we will do programming in OpenFOAM.